Hello. So today we're going to be talking about some of the terms and concepts related to sampling and surveys. So the first question that we need to think about is, what is the difference between a population, a census, and a sample? Now, these are words that we use all the time when we talk about surveys and sampling, but they're very easily confused. So as Lance points out, the population is the entire group of individuals that we want information about. Now, this doesn't have to be every single person in the world. It doesn't have to be every single animal or every single book in the world. The key phrase here is from the group that we want information about. So if we are interested in what students at Bayside High School are thinking, then our population is everyone at Bayside High School. We don't have to be talking about every single person in the world. A census collects data from every individual in the population. The most common example that you've probably heard of is the US Census, which is conducted every 10 years to determine the population of people in the United States. But in the real world, it's almost impossible to get a true census. So it's almost impossible to reach everyone in the population that we would want to. And so that's why we take a sample. Now, a sample is a subset of the individuals in the population. And so it's only some of the individuals, and it's from these individuals that we actually get data. So it's important that you recognize what is the population versus what is a sample. And then a census is associated with the population. Now, surveys are usually done from samples. And so pretty much every time we talk about surveys in this course, we will be taking it from a sample. And so let's move on here. So what is a sample survey? So as Gabriella points out, a survey, a sample survey can consist of people or animals or things. It's basically getting information from some sample. And this sample, the key concept about a sample is that it has to represent a population. You don't want to pick a sample that doesn't reflect the entire population, because if it doesn't reflect the population, then you're going to get a very flawed, well, it's a flawed sample, and so you're going to get flawed results. Now, sampling has a lot of problems. And one of the problems that we get with sampling is what we call a convenience sample. So as Quina points out, a convenience sample, as the name implies, a convenience sample is a sample, for lack of a better word, that is convenient. You're taking a sample from people that are easily reached, people in your class, people that are in your workplace, people that you know. They may not necessarily be representative of your entire population, but they just happen to be within easy reach. So convenience samples have all kinds of problems with them, and this is a very common flaw in sampling. Another issue with sampling is bias. Now, bias has a very specific meaning in statistics. When we talk about bias in statistics, we do not mean the bias that you probably think about when you hear the word bias. It's not something like, oh, I don't like Black people, or I don't like women. It's not that kind of bias. Bias has a very specific meaning. It means, as Jiwoo points out, some kind of consistent underestimate or overestimate of the value. And so the idea is that you are, perhaps we can think about this as a target. Now here's a target and there's the center of the target. If you are doing sampling that is biased, you would be getting shots that are kind of like that. And so you are consistently off. But when you are consistently off, you are off in kind of the same general way. And so what that allows us to do is to comment on what we call the direction of the bias. And the direction of the bias refers to, are you underestimating or overestimating? And how exactly are you doing that? And so as an example here, if you want to get an idea of how everyone in all students in the school are, you would not just survey students in the library, because as Jiwoo points out, this would probably not represent all students if you were asking, say, about their homework habits, because now we see here what Jiwoo wrote, we would probably overestimate the homework time or the homework effort or the quality of the homework, since the students who use the library tend to be more studious. So that would favor one outcome over others. So what would be a more representative sample of students? A better choice might be the cafeteria, depending on the school. If everyone has to sit in the cafeteria during their lunch period, then that would be more representative. Or the gym, if everyone in the school has to take gym, right? So whenever we talk about bias, you want to make sure that you don't just say, oh, there's bias, but that you also explain how that bias would affect the results. And that gets to this next question. When we talk about bias, what do? We find the problem with the design, as Jack points out, but then we also explain how that problem specifically would lead to an overestimate or an underestimate. You never just say there's bias. You explain what the direction of the bias is and why that's an issue, how that's an issue. Another issue, another problem that we have in sampling is what we call a voluntary response sample. Now, a voluntary response sample means that this is a situation where people are choosing themselves to participate. So Juliana points out that they are responding to some general invitation, meaning that anyone can respond, like an internet poll, in the sense that I'm going to put a poll up on my website and you can respond to it by going to this web page and answering the questions. That is a voluntary response sample. I am not forcing people to go to that website. I am not paying people to go to that website. I am simply making an open invitation, and whoever shows up, shows up. And this, as Juliana points out, usually leads to more biased responses, because who's going to make that extra effort? The people who feel more strongly about an issue. And so that would tend to skew the responses in a particular direction. All of these issues with sampling remind us that random sampling is really, really important. And so random sampling means that we take some subset that are of the population. They are randomly selected so that they represent the entire group. And so the goal here, as Priyanka points out, is to get a sample that represents the entire population. If your sample does not represent the population, it is not random, and it's really not a good sample. So what's a simple random sample? A simple random sample is, as the name implies, the simplest kind of random sampling that we can do. So the formal definition is that it is a sample of size n, whatever number n is, so that every group of n individuals in the population has an equal chance to be selected as the sample. And so the simplest example of a simple random sample, or an SRS, simplest example of an SRS is I take all the individuals in my population, I put their names in a big bag or a big hat, I shake it up, and I just pull out names, and whatever those names are pulled out, those are the individuals in my sample. So how do we take on our SRS without technology? We can picture drawing 20, let's say we're taking 20 out of 200. So I take 20 slips from a hat with 200 identical slips, and that's our simple random sample, because any 20 slips that I take have an equal chance of being chosen. Now, you notice that when we describe an SRS, or any kind of sampling method, we don't need to go into excruciating detail about how we are doing every single step. We kind of need to give a general idea as to how to do it. You notice that these explanations here are no more than 2 or 3 sentences. So don't feel like you need to write pages and pages on your sampling methods. With technology, we can do the following. We give each individual a distinct number. Then we use a random number generator to pick different numbers. And then there's one other thing I want to add here. Then we select the individuals that correspond to those numbers for our sample. So any kind of sampling technique has those 3 basic parts. You give each individual a number. Give each individual a number. Then you randomly select unique numbers. Then you choose the individuals corresponding to those numbers for your sample. You need to have all 3 of these parts in your description of sampling in order to get full credit. It's not just about choosing random numbers. You have to associate each number with an individual. And then once you select those random numbers, you have to actually select those individuals that correspond to those numbers for your sample. With a random digit table, this is not as common anymore on the AP test because, to be honest, no one really uses random digit tables anymore. We have so much technology available to us to randomly select individuals. So, but what we could do is we can read groups of digits that have the appropriate length across a line. We ignore any digits that don't fit. And we stop when we have chosen the proper number of labels. So simple random sample is one method of sampling, but there's another method of sampling called stratified random sampling. And so stratified is related to the word strata. A stratum is a layer. And so a stratified random sample involves dividing the population into smaller groups that we call strata. And so this allows us to provide more information because it allows us to identify specific groups that we think might be useful in understanding what's going on. Now, unfortunately, stratified samples often require more resources. So an example of a stratified random sample would be, well, if we wanted to survey students at Bayside High School, a simple random sample would be, we take the names of all 3,000 students, we associate each student with a number, and then we randomly select however many we need, let's say 30. We randomly select 30 students by randomly selecting 30 numbers using a random number generator. But a stratified random sample requires us to think, well, what groups might be interesting to us? What groups do we think would have different responses? So we might decide to stratify by gender. We might choose to stratify by class year. We might choose to stratify by GPA or by the math course they take, whatever it is. And so it requires us to think beforehand, before we gather the data, of how we want to divide up this information. A cluster sample is another kind of sampling method. In a cluster sample, as Menson points out, we group the population into clusters, and then clusters, each which are based on location, clusters need to be representative samples of the population. And then we can choose a simple random sample from within each cluster. Now, these are often easier to do when we have a large population. They tend to require fewer resources because it's easier to do a cluster sample. Cluster sample implies that we're going to go into this particular area, this particular cluster, and sample. So the example that I like to think about when we talk about a cluster sample versus a stratified sample is a cake. Now let's imagine that we have a cake with many layers. So a stratified sample would be, if we have the example of cake, if we have a cake with different layers, a stratified random sample would be we take a sample from each layer. Now that implies that we know what the layers are beforehand. And so if we can clearly identify layers, then in a stratified sample, we take a little bit of the frosting, and we take a little bit of the top layer, and we take a little bit of the bottom layer, and we take a little bit of the middle layer, and we take a little bit of the crust. So we identify the different parts, and we take a sample from each part. Now, what would a cluster sample be? Well, if we have a layer cake, a cluster sample has to be a sample in which whatever we take represents the entire population. So what would that be here? That would be a slice. A slice represents the entire cake because it has all the different layers in there. It has the frosting, it has the crust, it has the top, it has the middle, it has the bottom layer, all in one piece. So I don't have to go around and pick this part of the cake and that part of the cake and that part of the cake and that part of the cake. I just take one slice and I eat it. And it's all together, so I don't have to go all over the place. So that's what makes cluster samples easier to do if we can get a good cluster. Now, here's an example of in which we have 800 students present at an assembly. We see that the grades are divided by seat numbers here, 9th, 10th, 11th, and 12th grades. And so how do we choose a simple random sample? From our 800 numbers, we choose 80, just random 80 numbers. So it's the electronic equivalent of taking 800 cards, putting them in a big hat, and just picking 80 cards. And then we give the survey to the students in those seats. Now, what's particularly important here is that we did not just pick the numbers. We also, as we said here, give the survey to the students. So if you want full credit, you want to make sure that you say what you do with the random numbers after you've picked them. What if you have a stratified random sample? In a stratified random sample, we pick from within each grade. So we limit the number selection to each of the grades, and then we select randomly from within each sample. Again, that's like picking from one layer, picking from another layer, picking from the frosting, picking from the crust of the cake. And then once we select them, as I said before, you do what you need to do to those subjects. A cluster sample. The column of seats, if you look carefully at the way this is designed, each cluster of seats from the stage to the back could be used as a cluster. So we number these 1 to 20 because this is the cluster, this is the cluster, these are all clusters. And so we select 2 of these clusters randomly, and then we give the survey to those students in those 2 columns of seats. So again, the cluster sample is like the slice of the cake because we get a little bit from each layer of the cake. So random sampling is important in order to avoid bias and in order to allow us to make inferences that are trustworthy. We want to use chance deliberately. We're doing it on purpose. So we want to make sure that we understand the laws of probability, which we'll talk about in the next unit. But we also recognize that bias can never really be eliminated because, to be perfectly honest, you're not God. You will make mistakes. There will be some errors that will crop up. You will not be able to eliminate them. We will always have what we call a margin of error. What we want to do is to minimize that bias. We want to reduce the probability of getting a non-representative sample. So what is undercoverage? Now, undercoverage, these are some other problems that come up when we do surveys. So undercoverage occurs when we have members of the population that cannot be chosen. They cannot be chosen. So Jaron points out that if we want to do a survey of households. Well, the problem with surveying households is that you would not be able to reach people who are homeless or people who are in prison because they're not going to be included in that survey. So if you're trying to if you're trying to sample the entire population, you have to think about that. Another example of bias is what we call non-response bias. So non-response bias occurs when an individual that is chosen for the sample cannot be contacted or does not want to participate. And so This is often confused with voluntary response, but they're actually quite different. And so some people think that this is voluntary response because, participation is voluntary. But that's not the same as non-response. Non-response means that you have been chosen, but that you don't participate. Maybe you choose not to participate. Maybe you're not able to participate. That is not the same as a voluntary response sample. In a voluntary response sample, everyone has chosen to take part. So again, with the example of the internet poll, everyone chose to go to that website. So that is a voluntary response. But in a non-response would be, I send you a link to my survey by email, and you choose not to respond because you think it's spam. Or you never got my email because my email got sent into your junk mail folder. That is non-response. It's not voluntary response. Now, there's another kind of bias that is called response bias. Now, this term is a little confusing. Response bias refers to something about the interviewer, the gender, the age, the ethnicity, something about the interviewer that can affect people's responses in a systematic way. So one example that I thought of is a researcher asks women, how much do you weigh? But they do it in person, face to face. So think about that. What kind of bias does that introduce? When you ask a woman, how much do you weigh? You are likely going to get an underestimate of their weights because they may not be willing to tell you face to face what their true weight is. They might give a lower number. So that's an example of a systematic pattern of inaccurate answers. Women will consistently underestimate their weight in that situation. So how does the wording of questions illustrate bias? Wording can be very dangerous. If you phrase things in the right way, you can influence people's responses. Here's one example. Should illegal immigrants be prosecuted and deported for being in the US illegally, or shouldn't they? Now, just by reading this, it already puts a negative idea on the idea of illegal immigration. Even the term illegal immigration, it's illegal. That puts a negative connotation on it. They should be deported. They should be prosecuted. They should be deported. Why are they here? Now, consider another way of phrasing this. Should undocumented, actually I meant to write undocumented immigrants. Should undocumented immigrants who have worked in the United States for 2 years be given a chance to keep their jobs and eventually apply for legal status? Undocumented is a less loaded term than illegal. And when you phrase it as, they're working, should they get a chance to keep their jobs, that also kind of skews it in a different direction as well. Because now you're saying, look, these are good people. These are hardworking people. They should be allowed to stay. Versus the first one is, these are bad people that are here. They are breaking the law. They should go. So both of these are examples of ways that you can skew the wording of the question to influence the response. So you want to be very careful about how you phrase your questions so as not to do this, because both of these are skewed in a way. How would you do this to minimize this? Perhaps you would phrase this as, should undocumented immigrants who have been here, should undocumented immigrants be given a chance to apply for legal status or not. That would be less biased than the first or the second one.